Assigning the terms ground symbol for lithium. So here we have the lithium 3 atomic number 1s2, 2s1. So taking the outer shells, the valence electron shell, which is one orbital, there is one electron in it, and the name is 2s1. So straight away, after we drawing the box orbital, we assign the value of ml as 0. The ms is plus half, because it's a single electron. So the spin is a half, standing or with clockwise. So it's a plus a half. So now we come to count the ml. What is the ml for this? So there is one electron times 0 will be 0. So it's only one single electron we have. So if Al equals to 0, the term is S. Okay, so the spin we know is plus half. So the capital S, the total spin, is a half. So we have L 0, we have S half. Now we can do the 2S plus 1, which we need to know the superscript. So 2 times S is a half, plus 1 will be 1 plus 1, 2. So now the term symbol is S. The 2S plus 1 is 2. Just we assigned term symbol as L to S superscript plus 1 in brackets or parentheses, and then this will be S2. So you must make a big S as a term symbol. You have to put superscript to the left upper side. So that will assign or a value of 2s plus 1. So now if we go with the level term symbol, which is Lj, 2s plus 1. So the J is what is half filled. When there is a half filled or filled, the J equals to S. J equal S. What is the value of S? Is a half. So now we just replace J by a half. So the level term symbol will be S2 half. Beryllium 2s2, we have 2 electrons in the box orbital. So the ml is only 0 because it's a one box. The ms, you have plus half minus half. So the total will be 0. When the total of spin is 0, so S equals to 0. We come to the 2s plus 1. You just replace S by 0 times 2 will be 0 plus 1, 1. So it's a singlet term. Ground term symbol, 2s plus 1 L. The L is S. And the 2s plus 1 is 1. So because this is a filled orbital, so the J equals to S, as we said before. In the condition of the filled or half filled, the J equals to S. Now S is 0 here. So it will be the level term symbol, which has to be a J here. So we have a J and this subscript. So in this case, we have 2s plus 1 Lj is S1, 0. Yeah. Okay, we move on to the boron 1s2, 2s2, 2p1. We take the 2p1, the last shell, the outer shell. There are two outer shells, but the electron is, or we take the only the final shell. So 2p1, one electron in the box orbital. So you can assign the ml 0 plus 1 minus 1. So first you put the one electron, it's a one electron, you put it in the left side. So it's a rotating upper or spin clockwise. So it takes ms plus half. Now, ms is a plus half. ml, so we need to see the total of ml. We have 1 times plus 1. 1 electron times plus 1 will be 1. So the L, if it is 1, the term symbol will be P. Not because of this P. No. After counting the electrons, all of them, so we have 1 electron in plus 1. You multiply 1 times plus 1 will be 1. So if L is 0 will be S. If L is 1 is P. So the term symbol is P capital. S we have here total spin is half. And then we can count 2s plus 1. 2 times a half plus 1 will be 2. Doublet term. So ground term symbol is L to the superscript 2s plus 1 will be P2. So this orbital is less than half filled. To obtain the J, so the J, because it's less than half filled, so it will be L minus S. In all cases, we have to put the integer. Don't forget. So it should be an integer. So in this case, L minus S will be 1. L is 1 minus S is the spin, half. So it will be half. Now, the level term symbol is 2s plus 1 Lj. The J is a half. P is the term symbol. 2s plus 1 is 2. So it will be P2 half. Now, number of microstates. Okay, just let's do the state term symbol. 2j plus 1. So it will be this one is the state term symbol. L, 2j plus 1, 2s plus 1. So we have here is P2, and here obtain is 2. So it will be P2, 2. Number of microstates. Microstates are 2s plus 1 times 2l plus 1. So 2s plus 1 is being obtained here, will be 2, and 2l. What is L? You take it from here. 2 times 1 plus 1 will be 3. 3 times 2 will be 6. So 6 times we can arrange this electron 6 times. One is here, one is here, one is here. And here will be opposite, half a spin, half a spin, half a spin. So these are 6 times 6 can be positioned. This electron can be positioned. It's a probability. We are saying probability. Number of microstates, saying the probability of presenting one electron in these 3 orbitals could be here, 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 here. So that's the number of microstates. The carbon, if you see 2p2, the last orbital. So 2 electrons, we put them here. You can put on this corner ml plus 1, 0, minus 1. So now you count how many is the L capital. So they are total from the ml. So 1 electron times plus 1. plus 1 electron times 0, it will remain 1. So if the ml is 1 in total, so the L is equals to 1. Because the L representing the total mLs, the total. So the term symbol is P. We always put the term symbol in italic. Now, 2 electrons is spinning. How? Plus half will be 1. So the total of S is 1. Now we obtain, let me do this as capital letter. 2 spin, this is the total spin. 2 spin, total. So will be 1. So 2s plus 1, you just replace the s by 1, and you obtain it will be triplet term. Now, ground term symbol is this one, this value, which is P3. Because it is a less than half filled. What does it mean less than half filled? The p orbital filled with 6 electrons. Here we have, if half it will be 3, but we have 2 electrons. That means less than half filled. If less than half filled, we count. Again, should be integer. Because any number will come out should be in plus. So 1 minus. So it's a L. L is 1. S is 1. The total is 0. To J plus 1, you replace the J. This is the J. By 0, end up with 1. So now we can assign ground term symbol is P3. Level term symbol will be J, which is P. J will be 0. P3, 0. And the state term symbol to J plus 1, you just replace the J, each J by 0. So it will be 1. So the state term symbol will be P3, 1. Microstates 2s plus 1 times 2l plus 1. Now you have 2s plus 1 as a 3. 2l, 2 times 1 plus 1, 3. 3 times a 3, 9. So a 9 position, we can assign these 2 electrons. In 9, if you arrange them in the p orbital, the 2, so you can put 1 here, 1 here. This is 1 microstate. Second one, you leave 1 here, 1 there. This is second. Now you replace. You put 1 here, 1 here. This is third. Now you make them opposite or anti-clockwise. So it will be the same thing. We assign these for 3 states. If you make them opposite, will be another 3. So will be, and you can put 1 here, 1 here. And oppositely, so it will be 9 times you arrange these 2 electrons in this p orbital. Nitrogen here, we have 2p3, 3 electrons here. And don't forget, if you count ml, you have to put plus 1, 0, minus 1. 3 electrons, arrange them as they are. So we count the ml, total ml. 1 times plus 1, 1 times 0, 1 times minus 1. In total will become 0. So if the total of ml is 0, the L is 0, so the term will be S. You see? The orbital was P, but the term here became S. So what is the total S? Spin, we have half, half, half. All together, the total will be 3/2. Don't put 1.5. It's not allowed. There is no points, but you can do it as 3 over 2. So now we count the 2s plus 1. 2 times 3 over 2 plus 1 will be 4. And the 4, you can put it at the top here. This is the ground term symbol, S. Level term symbol, J. What is the J? J is a half filled. When it's a half filled, J equals to S. And S is a 3 over 2. So you put, instead of J, you put a 3 over 2. If you have the 2J plus 1, replace J by 3 over 2, you will end up with 4. So now the state term symbol will be S, 4, 4. So this is the spectrum of the nitrogen. The nitrogen spectrum shown above show distinct bands throughout the visible range. The blue lines is in the above were brightened for a greater visibility in the image. Oxygen, you have 4 electrons, 1, 2, 3, 4. Now total ml will be 2 times plus 1. No, I just wanted to do like, yeah. Yeah, that's to be precise. So these 2 electrons, we multiply them by plus 1. 1 electron times 0, 1 electron times minus 1. In total, 2 times plus 1, 1 times 0, 1 time minus 1, you end up with 1. So if the L is 1, the term symbol will be P. Now, total spin, you have half plus minus half plus half plus half. These will be 0. Half and half will become 1. The total spin S is 1. So 2S plus 1 is 2 times 1 plus 1 will be 3. So the ground term symbol will be P3. Now we come to the J, because we need to have the level term symbol, which is LJ 2S plus 1. J is what? Is it filled? Is it half filled? Less than half? More than half? These are 4 electrons. So these are more than half filled. When more than half filled, J equals to L plus S. And that will be in parentheses. So L plus S will be the value of J. L is 1. S is 1. So it will become 2. 1 plus 1 is 2. So I just made it quickly. 2J plus 1 will be 5. So the level term symbol will be P3, 2 instead of J. And instead of 2J plus 1 will be P3, 5. Number of microstates, okay? Microstates number. So it will be 2S plus 1 times 2L plus 1. So 2S plus 1 is a 3. 2L plus 1, 2 times 1 plus 1 will be 3, will be 9. So 9 arrangement will be for these four electrons. Fluorine is 5. And similarly, you can count. And in this case, you have the J3 over 2. You cannot put 1.5. It should be not digital, or it's a fractional. Should be fractions. And you can practice this, and you will find it's not easy, but on calculation, you can do this. And again, I don't have to do such a thing, but should be likewise. because the integer, we put it when L minus S. But when there is L plus S, you just put two small brackets or parentheses. Argon filled. So J equals S. Okay. So S here, the total spins are half minus half, half minus half, half minus half. In total will become 0. So when ML is 0, the term will be S. Okay. And when the MS, the total is 0, so total spin will be 0. So the L you have a 0, S is 0. Now you can find 2S plus 1 will be 1. And here you have J equals to S, which is 0. And you can assign all the term symbols, ground level states. And you can see S1, S1, 0, S1, 1. And that's the spectrum of the argon. Scandium, one of the transition metals, scandium, which is free. Don't forget, we are doing term symbol for the free ion, for the free scandium. No ligand, only scandium. So 4s2, 3d1. Now, someone say, how come 4s2 will be outer shell or 3d1? No, always the lower energy level will be 4s2. So the next higher energy level is 3d1. And in this case, you have one electron in d orbital. So you have to draw the box diagram of the d orbital, 5 suborbitals, and you assign ML plus 2 plus 1, 0, minus 1, minus 2. So you put the electron to the left and to the left. So now we can say ML, the total MA is 1 times plus 2. 1 times plus 2 is 2. So the total orbital L. If L is equals to 2, so the term symbol is D. You remember why? If L is 0, term symbol S. L is 1, term symbol is P. L is 2, term symbol will be D. So now you have the D term symbol. I like to do it italic, bold. Okay, now we MS, what we have MS, total MS is only one electron, so it's a plus half, plus half. So the total spin is plus half. 2s plus 1 will be 1 plus 1, 2. Now we have 2s plus 1 to the as a superscript, and here J is what? Less than half filled. You apply L minus S. So 2 minus L is 2, S is half, will be 1 and a half. 1 and a half, you have to turn it to 3 over 2. So 2J plus 1 will be 2 times J plus 1 will be 4. Now you have all the values. 2S plus 1, J, 2J plus 1. So you just put them in the ground is term symbol. D, 2s plus 1 will be what? So I just want to repeat this, just to say this is the ground term symbol. The ground term symbol is 2s, 1 plus 1, L. So it will be D2. Level term symbol will be with J. J is here, 3 over 2. And the state term symbol will be 2J plus 1 will be D2, 4. Microstates number or number of microstates, same thing. 2s plus 1 times 2l plus 1. So now 2s plus 1 is 2. 2l plus 1, 2 times 2 plus 1, 5. So 10. 10 times we can arrange. Who can say, how can we arrange this electrons 10 times positioned in these all orbitals? I will show you. First, you leave it as a clockwise spinning in this orbital. This is number 1. Or you put it here, number 2. Or here, 3, 4, 5. These are 5 positions for this electron. Or you can put it oppositely. The arrow will be down as a minus spin or a spin anti-clockwise. So you put here 1, 2, 3, 4, 5. So 5 and 5 will be 10. So 10 times I can organize or locate this electron in these 5 suborbitals. Could be. This is the microstates number, is the probability of this electron to be in one of these orbitals. In which position? Clockwise and anti-clockwise. Okay. Titanium, we have at the end 3d2. So we have 2 electrons, Ml plus 2 plus 1, 0, minus 1, minus 2. So now what do you have is 2 electrons in d orbitals. So you draw the suborbitals, 5 of them, because it's a d orbital. Put 2 electrons here. And now count the Ml. Ml, what do you do with the Ml? You say 1 electron times plus 2. Plus 1 electron times plus 1. Finished. So plus 2 and plus 1 will be plus a 3. So 3, what does it mean? The total L, if it is a 3, the term will be F. You see? The term will become F, as we said before. S when it is 0, L when L is 0, the term is S. When L is 1, term is P. L is 2, the term is D. L is 4, the term will be F. So you have the F as a term. And now you count the MS total spinning. The total spin will be plus half plus plus half. In total will be S1. Now you obtain 2S plus 1 will be 3. Now, because it's a less than half belt, you apply integer J equals to integral L minus S. In this case, L is a 3, S is 1, the remaining will be 2. So now you have 2. That's the value of 2s plus 1. Now we continue to have the value of 2j plus 1. We have the j. You just apply 2 times 2 plus 1 will be 5. The microstates, I put it here as a 2s plus 1, 2l plus 1. Okay, here we have the 3. Here you have 2 times 3, 6, and 1, 7. 3 times 7 will be 21. So 21 times you can position or locate these two electrons in all these orbitals, either clockwise or anti-clockwise. 21 times. Sorry. So the ground term symbol will be 2s plus 1l. Replace 2s plus 1 by 3 and will be F3. Level is with J and the J is 2. Put 2 here. So F3, 2. State term symbol will be 2J plus 1, 2S plus 1 will be F3, 5. Mercury is a filled orbital The final orbital with the Mercury 54 will be 510 D10. 5D10. So now J will be equals to S because it's a filled orbital. And this will be the last orbital, higher energy. So if you count the ML, you say 2 times plus 2, 2 times plus 1, 2 times 0, 2 times plus minus 1, 2 times minus 2. So all the value of ML will become 0. What does it mean 0? L equals to 0, the term will be S. 2S plus 1, 1. J equals S. Why? Because it's a filled orbital. So J equals S. S is 0. J will become 0. Now 2J plus 1. 2 times 0 plus 1 would be 1. Now we assigned all the values, the microstates, number, number of microstates. So a number of microstates will become what? So become 2S plus 1, 2L plus 1 times. So 1 times 1 will be 1. Now ground term symbol is this one, S1. Level term symbol J, S1, 0. J is 0 here. You see? So J I have is 0. And the state term symbol will be 2J plus 1 is S1, 1. So this is the spectrum of the Mercury. The prominent Mercury lines are at the wavelengths, these in blue, and one in green, and pair of at this nanometer, this and this, yellow, orange. So there are 2 other blue lines at this nanometer and this, and a weak line at 491 nanometer. So these are the spectrum for the Mercury, and we assigned all the values of the term symbols. Helium, you can do that, F11. So this is a big F, which is 7 suborbitals, starting with a plus a 3, 2, 1, 0, minus 1, minus 2, minus 3. So now we have all the electrons here, 11. We located them as Hond rule, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 7, 8, 9, 10, 11. So now we have 11. What you can do, you multiply. We need the total of ML to obtain the L. So you say 2 electrons times plus 3. 2 plus 2 electron times plus 2. This you add together, all together. 2 times plus 1, 2 times 0, 1 times minus 1, 1 times minus 2, 1 times minus 3. In total, ended with 6. Now the total quantum number, orbital quantum number will be 6. So what is the term of 6? Okay, you remember the term we started with. If L is 0, will be S, 1 is P, 2 D, 3 F, 4 G, H, I. So S, P, D, F, G, H, J. So I need to know exactly the term. Let me have a look where we put the terms before. This is the slide number 90 to see L equals to 6. I will go back to remember, just to be precise. These they are. So 6 will become I, the term symbol. S, P, D, F, G, H, I. So when you have a 6, L equals to 6, the term will be I. Okay. So we come back here and see it's an I. Scandio. Yeah, Holomew. So here we have I is the term symbol. And it is, let's make it bigger. So the term symbol is I. The unpaired electrons have a total spin of 3 times half. Why? Because every, like, half minus half, that will delete each other. So this, the total spin is 0, 0, 0, 0. So the remaining is half and half and half. In total will be 3 over 2. So now 2s plus 1 will be 2 times 3 over 2 plus 1 will be 4. Okay, this is more than half filled. So J value will be L plus S. What is the L? 6. What is the S? 3 over 2. So it will be 15 over 2. You see? So it like he is 7.5. What is 7.5 is 15 over 2. So you have to change it to fractional. And here 2j plus 1 is what? 2 times 15 over 2 plus 1 will be 16. So now microstates number of microstates, it will become 2s plus 1 times 2l plus 1, 4 times 13, because 2 times 6 plus 1, 13. Here is 4. 4 times 13 is 52. So now the ground term symbol, which is L, 2s plus 1 will be I. Instead of this value will be 4. Level term symbol J is what? 15 over 2. It's here. State term symbol 2j plus 1 will be 2 times 15 over 2 plus 1 will be 16. Number of microstates, I repeat it. Oh my God, what's this? So 2 times L. What is L? So it'll be 13. 4 times 13. Sorry. Here 2L. So it'll be 13 times 4 will be 42. So what did I do here? 13 times 4 will be 40, will be 42. So I repeated. This shouldn't be repeated. And now we have the number of microstates here, and everything is sorted. So what does it mean 42? Means we have 42 ways to arrange these 11 electrons in the in the f orbital. Californium have F10 similarly, so you can see and you can assign the 3-term symbol will become I5, I58, I517. Chromium, and this is another practice, will be S7, S73, S7 microstates will be 7 times. Okay. Copper. Aha, here the copper. So I wanted to show you the what's happening to the copper. And the copper, in this case, the copper have 4s2 3d9. So this is the normal electron configuration. But the copper, we know it as very stable because of not because of the last orbital is filled with electron and there is one electron left in the s. Okay, so now what you could count, because the 4s1 is involved, so now you count all of them including the one in the s. So it says ml is 1 times 0. This is the first time you experience such example. In the case of copper, you can transfer one electron to the d orbital to be filled and one remaining in s. So when you count ml, you have to count for all the 2 orbitals. So it will be 1 times 0, that's related to this one. 2 times plus 2, 2 times plus 1, 2 times 0, 2 times minus 1, 2 times minus 1. And in this case, this will become 0 and half will remain, sorry, 1 times 0 will be 0. In all cases, we have L equals to 0. The term will be S. And the MS is what? This will delete the other one because half minus half, half minus half, so all of them 0. Only this one is counted. You see MS is half. 2s plus 1 will be 2. It is half filled. When filled or half filled will be J equals to S. S is half, so will be J equals to half. So now 2J plus 1 is become 2. So the ground term symbol will be this S. 2S plus 1 is what? Is a 2. And the level term symbol, you apply J. This is J. Where is it? J. J is a half. 2J plus 1 will be 2. So S2, S2 half, S2, 2. Number of microstates, you multiply these 2 values will become 2. So only 2 arrangement we can do for these electrons. How? Can you tell me how? It's by these are, we cannot rearrange them. They are fully occupied. Only this one, you can assign it or locate it as a spin up or spin down. So either this way or opposite way. So I have only 2 ways of putting this electron, either clockwise spinning or anti-clockwise. So that's the number of microstates, which is very accurate. And you can practice same term symbols for silver and gold and this, okay, similar. So here, if you've been given, calculate the ground level and state term symbol for iridium. This is sample question. Okay. Anyway, so for the iridium, you can see the iridium is 77. The last orbital will be 5d7. Okay. So now 5d7 is what? you arrange them like this, and you can practice this and the similar way to before. We don't have a special case here to explain. So it's straightforward. And just here, you have a 3 plus 1.5 will be 4.5. Only in this case, I want to explain 4.5 is what? You have to make it fractional 9/2. You cannot put 4.5 here. It should be 9/2. Samarium ion. So here we have the samarium 4F6. Similar thing. I don't have a special case. Everything is 0. So the term will be these terms. And we can arrange them in 49 ways, these electrons. So you have here a full practice, and you can do that. I just put the, like, if you have ions, so you remove one electron from the outer shell, molybdenum +1. So you can see here 5s2, 4d4. So the losing one electron from the s, and the other one will immigrate to d4. Why? Because the d is 5 suborbitals. The more stable of the molybdenum +1 is to be like this arrangement. So what happened here? There are 6 electrons. One of them is immigrated to the d, become s1 d5. So losing one electron from where? From the s, remaining 5 electrons in the d orbital. So you count depend on these 5 electrons. You account L, S, J to J+1, microstates, and the term symbols. Here you remove 2 electrons from where? From the S. S will lose 2 electrons if you have such ion or cation. So remaining 4 electrons, and you can count the all values. If you have the molybdenum 3, so losing, they are all in total 6. You remember 6. So losing 3 will remain 3 in D. Thallium, here we have as it is, stands. So you have the d orbitals, 3 electrons, straightforward without any changing. So on, you can go ahead with, this is the answers for them. I hope they are accurate. And here you have more. For the iron, you have 4s2, 3d6. Losing 2 electrons from where? From the s. So you account 6 electrons in where? In the d orbital, and do your calculation. Iridium 77. But if you lose 1 electron from where? From the s, and the d orbital will remain. So you have here 2, 4, 6 electrons. You lost 1. So in this case, if you lose 2 from where? Iridium will be 9, losing 2 from the d, and they are stable like 5 electrons from the d. You lose 3 electrons from the d, but in this case, the arrangement will be what? 3 electrons will be more stable like this one. So all the d orbitals will be 5 electrons and 1 remaining. So you count 2 orbitals here. In the case of copper 2, you have lost 2 electrons from the s. And then 9 electrons remaining. These are the term symbols. Summary knowledge. Calculate the 3 term symbols for and microstates and number of microstates. For the free metal ion in cobalt in sodium. So now what you do, you will calculate depend on the oxidation number. You lost here electrons and see the cobalt oxidation number. Sodium, the nickel here, you depend on the nickel. So the nickel lost electrons because the carbonyl sodium, and you have to end up with how many electrons in the outer shell to depend on counting the 3 term symbols. Okay, so I stop here.